Hi guys, today we'll learn about equation of trajectory. So, equation of trajectory is nothing but the equation of its path. It is basically the relation between its x and y coordinate and sometimes z coordinate also. So, we can call that relation or the equation of path as equation of trajectory. So, how does it come? It is generally derived by eliminating the common parameter. Okay, so we will be deriving few equation of trajectory, and basically we are not talking about any general equation of trajectory. We will deal mainly equation of trajectory of a particle when it is thrown in a uniform gravitational field. Okay, so let's start with the first you can say it numerical or the derivation of equation of trajectory under projectile motion. Particle is thrown with speed u at an angle theta with horizontal from origin. Derive its path equation. Okay, so let's say a particle is thrown like this. This is x-axis, this is y-axis, and this is the path of the particle. Okay, y is not the maximum height. Okay, it is any general point on the path. So x and y coordinates are x comma y, and I can say x is the displacement in x, y is the displacement in y, and we have its velocities. X direction component of velocity is nothing but u cos theta, and the y direction component is nothing but u sin theta. So we have few variables: ux, u cos theta, uy, u sin theta, and there is no ax, which is 0, and ay is nothing but minus g in vertically downward direction. So what about x coordinate? X is nothing but ux into t, which is u cos theta t. What about y? Y is equal to uyt, which is u sin theta t, minus half gt square, half at square. Okay, so now x is dependent on t and y is also dependent on t. That is the only common factor we have. So we will eliminate that. So put the value of t as x by u cos theta in y. So what we are getting, y equal to u sin theta into t. T is nothing but how much? X by u cos theta. From this, t equal to x by u cos theta minus half g, the same square, x by u cos theta square. So what we get is x tan theta minus gx square by 2u square cos square theta. That is the famous equation of trajectory which we should remember. X equal to x tan theta minus gx square by 2u square cos square theta. There are some more forms of it which are famous. Just take x tan theta common. So what we'll get, y equal to x tan theta is common. We are left with 1 minus gx square by 2u square cos square theta multiplied by 1 by x tan theta. So when we solve this, it will appear like x tan theta 1 minus the single x will cancel. This is sin theta by cos theta, 1 cos theta will cancel, and what is left is x by 2u square cos theta sin theta by g. Just look at the denominator. We have range here. 2u square sin theta cos theta by g is nothing but range, or u square sin 2 theta by g. So the interesting form is x tan theta 1 minus x by r. That is another very useful form of equation of trajectory. These are the two famous forms of equation of trajectory. One more important point, that this point should be the origin, nothing else. The starting point will be the origin, and the projectile need not to be ground to ground projectile. It may be from a height or any other point. Okay, In the next question, we have to find the equation of trajectory. Let's start with the part A. X equal to 2t, y equal to 8t square. So we will eliminate t to get a relation between x and y equal to 8t square, and t is nothing but x by 2. So 8x by 2 ka whole square. So what we are getting? Y equal to 2x square. Okay, so this is nothing but a parabola. What about x equal to a cos theta, y equal to b sin theta? Whenever you get sin theta and cos theta and you want their elimination, so use sin square theta plus cos square theta as 1. So cos theta is what? X by a. And what is sin theta here? Y by b. So we can say, using sin square theta plus cos square theta as 1. So x by a square plus y by b square will give you 1. This is nothing but an equation of ellipse. This is parabola and that is ellipse. Okay. And a stone is thrown as shown. Find the range in terms of h, alpha, beta and theta. Okay. So in this question, theta is the angle of projection. U is the speed, which is not given. Okay, it is not given in terms of h, alpha, beta, theta. H is the height of a point at which point of projection makes an angle alpha and the point of fall makes an angle beta. So we can write this using cot. Let's name them. These are, let's say, PQR. So PQ or cot alpha is nothing but base by this. So PQ is h cot alpha. Similarly, cot beta is QR by h and QR is h cot beta. So what about range? Range, which is PR, is h cot alpha plus cot beta. So we can say, using the equation of trajectory y equal to x tan theta 1 minus x by r, u is not required or given here. Okay, so we should not use the other equation, u square sin square theta by 2g. This equation will give you the answer in the shortest steps or least steps. So x tan theta, x, this is the x coordinate. X coordinate is PQ. PQ is what? H cot alpha 1 minus x. X is again h cot alpha over h cot alpha plus cot beta. Okay, h will cancel each other and y is nothing but h. So this h will also cancel. We will be left with cot alpha. This is cot alpha plus cot beta, taking the LCM, minus cot alpha x tan theta. There must be some tan theta also. Okay, x was h cot alpha and we forget to write tan theta. So here should be tan theta, and in the denominator we will have cot alpha plus cot beta equal to 1. So just take these things here and we will be left with cot alpha cot beta over cot alpha plus cot beta is equal to cot theta. When we take tan theta at this side, we are left with this. So we can say this equation can also be written as just exchange the side. 1 by cot theta is equal to cot alpha plus cot beta over cot alpha cot beta. So this is tan theta is equal to 1 by cot alpha plus 1 by cot beta, cot alpha plus 1 by cot beta, and that is tan theta is equal to tan alpha plus tan beta. So this is the relation between alpha, beta and theta. Even h is not required. Okay.